Thanks for showing up. I appreciate you being here. I'm Chris Stoll. I am the Director of Product Management for Vutility. And just real quick on my background, I've been a maintenance engineer, I've been a SCADA engineer, distributed control system engineer. I've been in sales, working for companies like Honeywell, Schneider Electric, Rockwell Automation. So my background, have a lot of background in process control, industrial facilities, manufacturing. Also have some background in software, having worked for a company that sold enterprise software into the utility space, competing against SAP, Oracle, IBM. So rather broad background. This afternoon, I'm going to be talking about delivering real-time energy monitoring solutions for LoRaWAN. Going to give a brief overview of who Vutility is, what our products are, and hopefully spend the majority of time on use cases, and then have some time at the end for questions. So Vutility, we're a leading provider of real-time, high-resolution energy data monitoring. We believe that timely access to the right data at scale can deliver transformative insights to achieve sustainability, reduce waste, and improve performance and financial outcomes. So Stephen Prince, who's our CEO, he was supposed to be here speaking, and he sends his apologies that he wasn't able to make it. You get me instead. He says you can't change what you don't understand, and you can't understand what you don't see, which is really all about LoRaWAN, is to be able to see what you can't see and what has been too expensive to see in the past. So we deliver edge-intelligent energy fitness trackers focused in the commercial and industrial space. We do wireless energy metering. This is behind the utility meter. We are not focused on the utility side of the business. We're focused on the sub-metering side. Installed in minutes, non-obtrusive. You don't have to shut down in most cases to install our devices, and we'll talk a little bit more about that in a bit. It's better than revenue-grade accuracy. We have 3 products: Volt Drop, which provides voltage, current, power factor on each phase. We also provide apparent energy with it, and in the future we'll be adding harmonics to it also. Hot Drop is a self-powered, no battery, current transducer. Installs same way in that it is non-obtrusive and it can be installed hot. Pulse Drop is a pulse meter that can be hooked to gas meters and water meters to count the pulses coming off of those and transmit that data back using LoRaWAN. We have a large ecosystem of investors, partners, and end customers. We're installed in 20+ countries across 6 continents. We support US 915, EU 868, and AS 923-1. We're always looking to support more if the business is there for those. So most of you know why LoRaWAN, but LoRaWAN is very important for our products. Not only is it used around the world in a standard, but low power consumption. Our Hot Drop device is self-powered. It is gathering the power from the flux on the conductor. It's charging capacitors, and we have a very small power budget because of that. LoRaWAN is really the only thing out there that we can use to transmit data every minute because of that. So it's very important, the low power side of LoRaWAN. Also, we make the assumption that all of our devices are going to be put into electrical enclosures. They're going to be metal, you're going to close the door, and you're also going to have to transmit up through floors, whether it's in a hotel, etc. And so we need the power of LoRaWAN to do that. We had an example of this last week. Our devices were installed in a hotel in San Antonio, and they're inside of metal cabinets inside a metal room, and we're transmitting 4 floors up because of LoRaWAN, which is very, very powerful. It's, it's hard to believe that you can do that, but we did it. So long range is important to us too. We have some customers that are utilizing our sensors in a refinery, and they're transmitting a mile within that refinery. So that's very important to us also. Oops. Just real quick on our hot drops, because that is our main product. They go from 300 up to 4,000 amps. Again, they're wireless. They're a non-engineered solution. You don't have to do drawings for something that doesn't have wires coming to it. You don't have to be permitted to use these. So it's very quick, very easy to install, very accurate, secure, and using LoRaWAN. Quick to install, scan the QR code, snap it on. You'll see how you snap it on here in a little bit. And within minutes, you're getting data from our devices. So very quick and easy. Our solution set goes from utilizing gateways that we provide or third-party gateways, goes into our cloud, API out of our cloud to whatever solution you have, building automation, going to your own cloud, or we do have a dashboard that you can use. We are coming out with a direct version of Hot Drop that will allow you to go directly to your own LNS. Current schedule on that, I'm hoping, fingers crossed, testing will be completed and that will be out in the next 2 weeks on US 915. AS 923-1 will be out hopefully 2 weeks after that, and EU 868 another 2 weeks after that. So hopefully we have all 3 of those out by the end of June is our target for that. So now let's get into case studies, things that we've done with our devices. So a major healthcare provider, 200 plus hospitals, 2,000 clinics, has started rolling out our devices into their facilities. It started out that they wanted to go into a number of their hospitals and do energy audits to support their ESG requirements. We're installed, I believe, now in 8 hospitals, 1 warehouse that they have. And it's really interesting because we've gone in all these installations, we have not de-energized 1 circuit. 100% hot, we've installed these. Now, I have to say, when you do that, you do need to follow all applicable safety rules. Okay, when we installed, they were all installed with gloves, non-conductive gloves, and in one case, they had to don an arc flash suit to install it. But that's way less expensive than kicking over to the diesel generator, shutting down parts of the hospital. So that was a huge win for them. So that didn't cost them much at all. So through the audit, one of the things that we found was a severe phase imbalance. And their energy provider at this hospital charges based upon the power used in the highest phase. So the power in that phase, and I'll show you an example from our building at our headquarters. That was costing them $200,000 plus a year because of those added charges. So they've now gone back in, rewired their branch circuits, and leveled out and balanced their load. So this is an example of what I'm talking about. This is actually from our building in Sandy, Utah, where we have hot drops installed there. And you can see on the right-hand side that phase C is more than phase B is more than phase C. And it's quite a bit of unbalance with it. Now, these loads aren't that great, so the benefits of balancing these loads may not be worthwhile. And what we're doing right now is we're bringing a consultant in who is going to work with the owner-operator of the building, and we're going to go ahead and look at what their costs are because of this, if Rocky Mountain Power, who's their energy provider, charges this way, what the value would be to make those changes, what the cost would be, and do a cost-benefit analysis. That, and also within that building, there we go, we have a volt drop in there, and this is doing the power factor. And Rocky Mountain Power does charge more when your power factor drops below 0.9. And you can see this one is dropping below 0.8. So they're definitely paying more because of this power factor. When the consultant comes in, he's going to be looking at that and see what it would take to remediate this issue. So hopefully, when I come back next year and present, I'll have the results of this to present to you, or one of the other conferences coming up. All right, this is a very interesting case study here. This is an RV park management company, and their issue was that traditionally what RV parks would do and the management companies would do is 12 to 18 months before somebody would show up into the park, they would have to set the rates for each campsite. And so they would have to look at and estimate what energy costs were going to be at that time. And they were in a position where if they estimated too high, they may lose business because people wouldn't stay there because their costs were too high. If they estimated too low and energy prices go up, now they're stuck holding the bag and their margins are hurt. In fact, they had one year that it really almost crushed the company. It was that bad. Energy prices went up so much. So they were looking for a way, how do they go in and very quickly start monitoring every campsite? So what they did was they went in and put our hot drops in at each campsite. Each campsite had two 220 volt two-phase breakers, one 110 volt breaker also. And now they're able to go in, they're able to meter this. Somebody comes into the campground, signs in, they grab what the odometer is, how many amp hours are showing on the odometer on the hot drops. They're able to then do that again when they go out, take that difference and charge them for what they're using. Things that come out of that, the person who's pulling in with a little pop-up camper that's just running lights and fans and maybe a water pump is now paying for what they're using, where before they were covering the big bus or big trailer next door with two AC units and that. Second for them is from an ESG standpoint. It's been proven that when you start giving people how much energy they're using when they're not used to having it, they will drop their energy usage on average by 30%. So they're expecting to see a very large drop in their energy usage. So this allowed them to de-risk their business. This one here, motor monitoring in an industrial plant. This is near and dear to my heart. I've spent time in all these industrial plants. I know the processes. I know how they make money. So what the problem is most of the industrial plants in the world have old electrical equipment. It's not being monitored. If it's a motor, they have old electromechanical devices that will shut down the motor when the current gets too high. And that's to protect the motor, it's to protect the wiring, etc. So they can't see this. And because of this, in a lot of cases, and in this refinery, they run the process below where they need to guarantee that they will not shut down because the motor trips. And that's usually quite a bit below, so very conservative. A shutdown in a refinery costs way more than that lost production. So they're more than willing to give that up. However, they want to now see that and start to use that. So the other thing too is the cost to utilize standard instruments to wire them in is going to require a shutdown, which they don't want to do. Refineries never plan to shut down if they can help it. The other one is refineries have what they call management of change. Other industries have something similar. Nuclear industry has to meet the NRC rules in the US. Some manufacturing companies like airplane builders have quality concerns, and they have to go through a management of change if they change anything within their system to make sure that the quality is there. So this management of change says anytime you start to wire something up, you're going to have to go and engineer it, design it, you got to go through HAZOPs, and the cost becomes almost prohibitive for them to do it, and it's kind of ingrained in them that they just don't do it. So we were able to come in with hot drops, install them while it kept running. We didn't shut them down, and we were able to do this within minutes, and within hours, they were able to start optimizing the process. And in one case, their benefits were over $400,000 in 1 week. It was actually significantly over. I'm trying to be conservative. But it was actually on one of the pumps that was charging their crude unit, 150,000 barrel a day refinery, that they were able to run 3 to 5% more through that refinery just because of our hot drops. And if you start running those numbers with 52 gallons per barrel, et cetera, you start to see those numbers get really big really fast. So now I'd like to show you how you install a hot drop. You notice the glove too. Safety first. So the comment, stupid easy metering, that was from one of our partners. So that's exactly what they said. All right, any questions? Is there a microphone? I probably can hear you. Do you have any questions? We don't yet. We're working on that. If you have some ideas, I'd like to talk to you. We are investigating that right now. So just real quick with that, I've been in my position for less than a month right now. Definitely on my list to build that out. Any other questions? All right, well, thank you. I appreciate your time.